All right, we're going to solve equations, but we're going to break down this process with a few problems. And we're going to focus on first simplifying and then doing inverse operations. Now with this problem, since there's a fraction there, I don't really want to deal with that fraction just yet. The gut reaction you might have would be to distribute. However, it's going to get ugly if we do that. So we are going to do some inverse operations first. First thing we're going to do is we're going to add 3 to both sides because the opposite of subtraction is addition. Okay, now I want to get rid of that fraction. And the best way I'm going to do that is to try to get rid of this 2 here. Well, what's the 2 really doing in our problem? It's dividing. What is the opposite division? Multiplication. I'm multiplying the entire side by 2. That's why these 2 can reduce, and this becomes 20. And I'm left with -3 times x plus 4 equals 20. Now, we could divide both sides by -3, or we could distribute. I think distributing now would be easier because we have a whole number. It's not as ugly. Okay. So now we have to isolate the variable, use some inverse operations. Opposite of subtraction, addition, opposite of multiplication here is division. We get x equals -32 over 3. There we go. All right, let's try another one. This one I'm going to distribute just because it's a whole number, it's easier to work with. Make sure you only pass out to what is in parentheses. So distribution is multiplication. We get 2 times x is 2x, and then 2 times 3 is 6. Okay? And then voila, our parentheses is gone. But we've gotten rid of our parentheses, we got a whole bunch of stuff. So unlike the previous problem, we have a lot of like terms on this problem. So what we want to do first is collect all our like terms on one side, and then move things around to isolate the x. So these cancel out because 6 minus 6 is 0. I can get my x's together by subtracting because this is positive. The opposite of addition is subtraction. I get a -3x equals 1. Then I divide both sides by -3. And my value for x is -1/3. First, we simplified, then we combine like terms, and then we use inverse operations to get the x by itself. I think it's important to have a side note here with equations. Now, equations have 3 types of solutions. What we just looked at were 1 solution. What are the other 2 types? Well, that's what we're going to look at now. Now, our first type of solution, okay, was 1 solution. Let's see what this problem shows us. First, simplify. Combine those like terms. (12 minus 9 is 3x plus 7. Remember, we're only combining the coefficients on like terms. And like terms have the same variable and the same exponent on that variable. So now we have to get our x's together by using some inverse operations. They're both positive. We subtract 3x on both sides. They reduce. We're left with -5 equals 7. When does -5 ever equal 7? Never! That's why it's no solution. Let's look at a third solution type. Okay, again, simplify. We can distribute here. I get 5x minus 20 equals 5x minus 25 plus 5. Combine some like terms here. I get 5x minus 20 equals 5x minus 20. Interesting. Let's keep going here. Subtract 5x. Subtract 5x from both sides to reduce that. I'm left with negative 20 equals negative 20. Okay? So negative 20 will always equal negative 20. That's why this one is infinitely many solutions, because negative 20 is always equal to negative 20. It's always true. That means there's infinite solutions and infinite values for x. Inequalities are similar to equations in the sense where there's a number of solutions that make the statement true rather than one, none, or infinite many. Graphically, how do we see this? Well, for a solution like this, it's a single point. So if we look at a number line, it's just that one point on the number line. All right, we're going to solve these using a similar process to equations. Then we're going to compare them afterwards. But the first thing is simplify, combine like terms, isolate the variable using inverse operations. So we're going to solve both, and then we're going to compare. So I'm going to distribute to try to simplify this first. I get negative 33 minus n is less than or equal to negative 6n minus 3, because distribution is multiplication. Then I add 3 to both sides to get negative 30 minus n less than or equal to negative 6n. Then I add n to both sides to get the variables together. I get negative 5n, and then I divide both sides by negative 5. I get n is greater than or equal to 6. But wait, whoa. When I divide or multiply by a negative, something special happens. Uh-oh. When I divide or multiply by negative, the sign has to flip. There we go. We fixed that. Let's look at this one. Okay, again, simplify. We're going to distribute first to simplify. I get negative 10b minus 35 plus b less than negative b minus 11. Key thing here is combine like terms. Okay, we're going to combine our b terms to get negative 9b. Notice how I added those together because they're on the same side of the inequality. Negative 35 less than negative b minus 11. Okay, so now how do we get other pieces together? Well, again, we continue inverse operations. Add b to both sides, get negative b minus 35 less than negative 11. Okay, then we add 35 to both sides, get the whole numbers together. I get negative 8b is less than 24, divide both sides by negative 8. Uh-oh, dividing and multiplying by a negative again. What's going to happen? Got to flip the sign. Flip it. I get negative 3. Okay. So the comparison I'm talking about is not with the process. As you probably can notice, we went through a very similar process. It's the graphing portion. Okay. So on the number line, this one would be a filled-in circle. This one would be an open circle. Since it's equal to, that means it's included. Since this is not equal to, that means it's not included. Now we got to talk about the direction of the arrow. Okay? So there's two different ways you can see this. You can see b greater than negative 3 or negative 3 less than b. Both are equivalent. Over here, we could see 6 is greater than or equal to n, or n is less than or equal to 6. So I know that numbers less than or equal to 6 are over in this direction. So that's why I'm going to shade to the left. And I know for this one, the numbers that are greater than -3 are to the right. So that's why I'm going to shade to the right. But the question is, how do I know that I'm sure every single time? Well, worst comes to worst, you could always test a point like this. So I'm going to use the original solution of b greater than -3. I'm going to test 2 points. I'm going to try -2, because I know that number is greater than -3. That works. Let's try -4. Is -4 greater than -3? No, that doesn't work. That's why we have to shade to the right. Same process over here, okay? For 6 greater than or equal to n, I'm going to test 2 points. I'm going to test 5 and 7, because they're on opposite sides of the 6. So 6 greater than or equal to 5, it works, we're good to go. But is 6 greater than or equal to 7? No. That's why we have to shade to the left. So to check your graph, to make sure you're accurate, to make sure that this is the most accurate drawing, I highly recommend you test points. And those points will show you if you've really gone on the right path. All right, let's talk about creating equations, inequalities, and context. First, we're going to read through the problem, and then we're going to talk about it on the sideboard, try to figure out how to solve this. So Danya and Shema were saving up to buy the new phone that costs $450. They need at least $450. Danya knew she had $200 already at home and was going to earn $60 each week. Shema has to pay $20 each week for gas, but she earns $80 at work each week with $100 already in the bank. After how long will both be able to have enough money to buy the new phone? All right, when solving an equation, first thing we need to do is define the variable. So what is the thing we're trying to find? Well, for both Shema and Danya, we're trying to figure out after how many weeks it takes them to earn enough money to pay for that phone. So, for Danya and Shema, the unknown is W, which we could stand for weeks, the number of weeks. Very important to define the variable. Second, we're going to try to make, there's 2 separate things going on here. We're going to focus on Danya first, and then we'll get to Shema. So it says that Danya knew she had $200 at home already. I mean, she already had it, okay? She's going to earn $60 each week. But she needs to have at least $450 to get that phone. Does that mean it's equal to? No, because if she's earning money, she's not going to stop earning money, but she needs at least enough money to buy the phone, but she can continue to earn money after that. That's why we think of as an inequality, because she wants at least so she can be greater than or equal to the amount of money she needs. She needs $450, but she can always earn more than that. Okay? That's why it's greater than or equal to. Okay? We'll talk about solving this in a second. For Shema, it's a little bit different. Shema had to pay $20 for each week for gas. But she's paying. That means she's losing money. That's why we can think of her as -20 because she's losing $20 a week to get to this job. But at that job, she ends up earning $80 per week. Now, she needs at least $450. So that's the idea of greater than or equal to. Well, I almost forgot something. What did I forget? Well, Shema had money in the bank too. She had $100 in the bank. So we just got to figure out after how many weeks is Danya good and after how many weeks is Shema good. And that's how we go through the process of solving. So again, we had to interpret different parts of the expressions to break it down bit by bit. Okay? So, we're going to solve it ourselves. We're going to use inverse operations like we did before in solving equations. So you get 250. You got to divide 60 on both sides. You get W is greater than or equal to 625 divided by 6. Okay? Now, we're going to talk about that value in a second. We're going to simplify this first. Negative 20 plus 80 is 60. We're combining like terms. 60W, I'm sorry. Then we have to do some inverse operations to get the W by itself. We subtract W from both 100 from both sides. I get 60W is greater than or equal to 350. I divide 60 on both sides. I get W is greater than or equal to 35 over 6. Okay? So we're going to talk about this idea. So we got two fractional answers here. All right, let's talk about the solutions we found. So I'm going to go ahead and divide this. I get W is greater than or equal to 4.16. And then W over here is greater than or equal to 5.83 about. Okay? So I should probably label this, right? Yeah, because we should use units. So it's weeks here and weeks here. Now the question asks after how many weeks? What do we know about these solutions? Well, she's not really gonna have money in the middle of the week. It's after she gets every paycheck each week. And same thing for Shema. So in the context of the problem, it's really gonna take her at least 6 weeks to get the money she needs, because she doesn't have enough just yet at 5. She has to wait till after that 6th week. And for Danya, it's the same.